So let's just do a really quick question first. What is energy? So energy, I know this is a very circular definition. Energy is the ability to do work. And so there's a couple of types of energy that we're interested in. There's lots of different types of energy. I mean, there's things like electrical energy, nuclear energy, solar energy, acoustic energy, thermal energy, lots of different types. But most of the time in engineering, we're interested in stuff that will actually let us make things move and we can use. And in physics, we're interested in energy because we're interested in everything, basically. So what is energy? So potential energy, let's look at potential energy. Potential energy is energy that has the potential to do work. Potential. And I mean, again, so different types of potential energy. We have things like chemical potential energy, which is used in in batteries. We have spring potential energy, which is used in clockwork mechanisms. But let's look at particularly gravitational potential. And this is often used in reality. So every time you lift up a weight or such like and let it come down, like on a cuckoo clock or something, it makes the hands move around. That's applying work, a force. The force makes the hands turn around. It's applied over distance. That means work is done. That means there was energy in there. So the amount of energy, E potential, well, let's just use energy potential, gravitational potential energy is related to several things. There's the mass. The more of the substance you shift up the hill, the more energy it has. There is also, so we've got mass, and that's going to be in kg. Another thing that's important is your gravity. On Earth, that's what, 9.8 meters per second, but we'll often use 10. And the other thing that's really important is the height. How high do you shift this? If you lift something up, 10 meters, it's got more energy than if you lift it up 1 meter. And I mean, I have actually been up the top of the Empire State Building, and there was a little sign on there saying, do not throw pennies off the building because they've got a lot of potential energy. So potential energy, so we're going to use this as gravitational potential, and that's going to be measured in joules, same as work. Work is the change in energy, so work and joules are going to have the same unit. So let's do a couple of examples. So 2 students, we just did this just before, I believe, students in the work section use a pulley system to raise a 300 kg piano 5 meters. So this is exactly the same problem I used in the energy, in the work section. So what is the potential energy? Potential energy. So draw a picture, a couple of students lifting up a piano. So EP equals mass times gravity times how high did you lift it? So we should just put the change up, which is equal to, mass is 300 kg Gravity, we're on Earth, I'll just use 10 meters per second squared because it makes the maths easier, and it's still accurate to within 2%. How high did they shift it? They shifted it 5 meters equals 15,000 joules. So we did 15,000 joules of work. There's a change in energy, potential energy of 15,000 joules. So as we lift up that piano, it gets 15,000 joules of energy. So let's just try another one. Skier, 70 kgs, is at the top of a 120 meter high slope. What is their potential energy? Potential energy. So we have a skier, some skis, and we have a slope, h equals 120. So write down what we know. Mass equals 70 kg, h equals 120 meters, g is going to be Earth. I'm going to use 10 meters per second squared, but if you're more advanced, feel free to use 9.8 or 9.81. EP equals mgh. So at the top of the hill, they're going to have 70 kg times 120 meters times 10 meters per second. What's that? 1200, 84,000 joules of energy. Cool. So we'll extend this, and we'll probably use this later and continue this in an example of conservation of energy. We'll probably use that one again. Okay, cool. So we'll see you shortly.